important that you keep a couple things in order when you do these problems. One, what am I starting out with? And two, where do I need to end up at? And so the problems we just did, they're giving us moles of one reactant or product, and they're asked to find the number of moles of another reactant or product. Okay? And that's what it's doing. So I might have you do an activity on Friday. I'm not sure if I'm going to or not because I don't have it made up yet, and I might just wait until we get back. I want to show you how these Legos, yes, Legos, work. Okay? And kind of show you kind of what's going on with these Legos. With this example, okay? The first part of it. So, we just write this number. You can automatically take that number and write it out in front. 0.425 moles of Al2O3. Again, I would say the students, and they're not, I would say all the students that wrote out their units and was very detailed, majority of them, not all of them, I can't say all of them, but majority of you guys that did that were successful. Okay. And so the first thing I have to do is make sure I balance this equation. So that's 4, 3, 2. You guys know about balancing. Okay. Now, what it wants to do, well, it wants to find grams of oxygen. So oxygen's O2. Okay. So grams of oxygen is O2. So I need to go to grams. So basically I'm starting off right here with 0.425 moles of this. And I need to come over here to grams. Okay, I'm going to put grams. I like writing my grams above and moles below just to kind of keep the units separate. So I'm going to go to grams. Okay, this is where I want to end up. So I need to get here. I need to get to this spot where I get that value of grams. Okay? So what can we do to advance forward so that we can eventually find grams? Because we can't do it in one step. We have the amount of aluminum oxide, but we don't have the number of molecules or units of aluminum oxide, but we don't have the number of molecules or particles of O2. So what would you suggest, based upon what we did yesterday, that I would need to do before I can find grams of oxygen?
Find their total mole amounts.
Okay? There's one thing I would do. So let's do that. So I'm going to go ahead off the side and I'm going to say O2 is each one 16 grams. Take it times 2. And so that would be 32 grams per mole. Okay, so that's one thing I would need to do. Very good. But it doesn't get me to grams yet. So this is moles. So what would you think would go down here?
A mole.
Mole what?
1 mole of Al2O3.
Okay, Al2O3. Now let's be careful because we're used to using 1 all the time. We're used to because we're comparing grams to moles. So let's be careful to kind of know where we need to go. So we need to go to oxygen. What do we need to find in oxygen so that we can find the grams of oxygen? What in here, in this I'm going to rewrite that. 32 grams per mole. Okay, what in here, unit, am I going to need before I can find grams? Moles. Moles of what? Oxygen. So I'm going to put moles of oxygen up here. Does that look familiar? Alright, so every single problem has a mole-to-mole problem like we did yesterday. So what numbers, or what numbers should go in for moles of Al2O3? 2. Everybody see that? Why not 1?
Because for every 3, O2 should get
Yeah.
2 Al.
So yeah, right. Awesome. For every 3, you got 2. Okay? Now, when do we use 1 mole? When we're comparing it to what? Grams. We use 1 mole when we compare it to grams, because that's what we figure out with the molar mass. So what value goes up here for O2? 3. Question with that. Alright, now we're one step closer to completing this problem. One step closer. Now, I don't want to do all these separate little individual calculations. You guys remember when you guys did, for example, maybe centimeters to feet? And maybe you would go, okay, if I had 30 centimeters, what would I do the first step? Go centimeters to inches. And for every 1 inch, there's 2.54 centimeters, right? And then the next step, you do what?
12 inch to 1 foot.
12 inch to 1 foot. See how I did that all in one setup? And I did not have to change I didn't have to go 30 divided by 2.54 equals. And then do a second step, and then a third step. I did it all at once, right? So guess what I want to do here? I want to keep going until I get my answer in what? Grams. Okay, so then what unit and what substance does that unit represent go down here? Moles of what?
O2.
O2. Can we make a connection between moles of O2 and grams of O2? Yes, because it's our molar mass. Right here. Because that says for every 1 mole, you have 32 grams. Any questions you have on that? So then we just multiply it out. And we get our answer. Okay? So we're just going to go 0.425 times 3 divide by 2. Make sure when you guys are doing this you press equal every time you do a function. Every time you plug in a function, make sure you're setting it, you're doing equal. Because you don't want to go 0.425 divided by 2 times 3. You know, that looks like it's all on the bottom of it. So you got to be careful with that. So your answer is going to be 20.4 grams of oxygen. Any questions you guys have with that setup? Alright, so here's the map. We start off with moles. We've got to find moles of something else if we want to find the weight of it. I mean, you have to find the number of particles of something else, and we call it moles, of something else before you can find its weight. And so a lot of times students will do this. They'll mess this up by putting their moles of Al2O3 down here, and they'll put 32 grams up here. Well, that's 32 grams of oxygen. That doesn't have anything in relationship to moles of Al2O3. So you always got to go through moles before you can go to grams. Does that make sense? You got to go through moles before you can go to grams. Okay? So I'm going to give you a second type of problem on this. Okay? So, I'm going to have you do that problem, and you can use the setup on the other one I did as a guide. Okay? So, we're starting out with 7.6 moles of hydrogen. And we're trying to get to grams of ammonia. So go ahead and do that. Yep. I'm doing this. So I'm going to put 7.6 moles of H2. Down here I'm going to put moles of H2. And up here I'm going to put, there's a tendency to put grams of NH3. You can't do that because they're not the same substance. It's not an apples and oranges comparison. You can't do that. But up here I'm going to put moles of NH3 because I want to go over here to moles. That's the first thing I do. Then, now that I got moles of NH3, guess what I can do? I can go to grams of NH3. So in here should go 3 and 2. In here it should go 1 and 17. And then you have your answer. Then you have your answer. So we're able to connect moles and finding weights because that's important in lab activities when we have to do that. Because we measure out grams. So the answer is going to be 86 grams. Question? Okay? We're going to do, I know we're short in time, we're going to do one more that's kind of backwards of what we just did. Alright? And so the one that's kind of backwards of what we just did is going, that's the one we just did. Okay. This is the same type of problem, so there's not a whole lot that we're changing here. So now we're given 12.5 grams of hydrogen. Where do we need to go? What do we need to find? Moles of, this is ammonia. So we got to find moles of ammonia. We got to get down here. Okay? So this is called a mass to mole problem. Okay. So you tell me what I need to start with. 12.5 grams of H2. What's my next step?
How many grams are in 1 mole?
Yes, how many grams are in 1 mole? So grams of H2 to what? Moles of what? H2. Why do we got to get moles of H2? So we can make that relationship mole to mole, right? So down here goes what? For H2, 1 hydrogen is 1.01. I've got 2, so that's 2.02. And up here would go 1 mole. So now we're here if we do that calculation. So my next calculation is to go moles of H2 to what? Moles of NH3. And so it's backwards of the one we just did. So what numbers go in there?
33 moles of H2.
3 of H2 to 2 of that. And that's it. So it's backwards of the one we just did. So when you guys come in tomorrow, you're going to be asked to do some problems like I just have went through. And so this would be 4.13 moles of NH3. So when you guys come in tomorrow, who's not going to be here tomorrow? You're not going to be here Friday either? Okay. So you need to come and get this sheet. If you're going to be here tomorrow, this sheet will be given to you guys so for you to work on. All right? So Then there's one third type of problem we didn't get to today, and I'm just going to put that on Google Classroom, and you can watch that so that you can complete the thought process of doing these type of problems. So.
I can stop by tomorrow morning.
Nope, I've got it here. Yep, take that. If you're taking a test, a retake, it'll be available in here with the sub. You're going to have to make arrangements with the study hall teacher, or come in here and take it Friday night period, or however you need to do it. Okay, because I'll be gone on Thursday and Friday.
Are we doing like a Lego lab on Friday?
I don't think we will. We'll see. Maybe. I'm working on it today.
Do we need that sheet done if we're not